Alright, this is the Lesson 8 homework. Simple transformations of sine and cosine. So, for the first problem, we need to know how to graph sine and cosine. Otherwise, how are you going to transform it? So, what I want you to do here is graph two complete periods. So when you see the word periods, you're going to think repeats. So two complete repetitions of sine and cosine. So we'll do this on two separate graphs, and it says starting from any angle of your choosing. So you can start from wherever you want. Just draw it out until it repeats completely twice. So I'm going to start. Let's do sine first. Because I can start wherever I want, for sine I'm going to start from 0. And when I say starting from 0, I mean an angle of 0. That should be far enough. So, here would be 0, and then I'm going to count by fourths of pi. Actually, I'll just count by degrees. Why not? So there's 90 degrees, 180 degrees, 270 degrees, 360. So I'm setting this up so that each dash is 45 degrees. 405, 450. Now, how far out do I need to go to get two complete repetitions? Well, remember, one circle is 360 degrees. So to get two repetitions, I need to go around the circle twice, which would be 720 degrees. So that would be 540. 630. 720. There's two complete circles. That should be enough space to give me two total repetitions of the graph of sine. So, as a visual aid, here's a little circle. So first off, I need to know what sine of 0 is. So 0 is right there. The sine value, the y value there, would be 0. So sine of 0 is 0. The next angle is 45 degrees. So here, I've got 45 degrees. I need to know what the sine value is. So sine's the y value. It's a 45, 45, 90, so it's going to be square root of 2 over 2. So over here, at 45 degrees, on the x-axis, I'm going to put square root of 2 over 2 on the y-axis. By the way, I should mark my y-axis. Let's say that 1 is going to be the highest I ever go, negative 1 is going to be the lowest. And back to what I was going to mark. Square root of 2 over 2 is the sine value at 45 degrees. So here's 45 degrees. I'm going to go up to square root of 2 over 2, which is about 0.7. Now at 90 degrees, I need the sine value. The sine value there would be 1. So at 90 degrees, I have 1. At 135 degrees, that would be here. At 135 degrees, my value for sine would be square root of 2 over 2. So 135 square root of 2 over 2, 0.7. At 180 degrees, my sine value would be 0. So 180, my sine value is 0. 225, my sine value is negative square root of 2 over 2. 270, my sine value is negative 1. So hopefully you see what's happening here. I'm going to go a little faster. 315, negative square root of 2 over 2. 360, sine is 0. At 405, same as 45, sine is square root of 2 over 2. At 450, same as 90, sine is 1. At 495, sine is square root of 2 over 2. At 540, sine is 0. At 585, sine is negative square root of 2 over 2. At 630, I lost my spot. Now, at 630, sine is negative 1. At 675, sine is negative square root of 2 over 2. And then at 720, sine is 0. So I'm going to trace this line in, connect the dots, try to do a good job. So, there I have one wave, two waves. So a complete up and down, and then back to the starting place motion would be one wave. So this would be a single period right here. So I have two periods. Oops, one period. I have two periods in total. So here's one, then there's another one. Each period here lasts 2 pi. One complete revolution. Let's try cosine. Cosine. I'll start from 0 again. And this time, just for practice, I'm going to label my axis in radians. So instead of 90 degrees, I'm going to have pi over 2. So here I'm counting by halves of pi. But I'm going to go ahead and put a dash in between each one, which would be, say, 1/4. So this would be 1/4, 2/4, 3/4, 4/4 of pi, etc. So there's 3 pi over 2, 3 halves of pi, 4 halves of pi, which would be 2 pi, 5 halves of pi, 6 halves of pi, 7 halves of pi, 8 halves of pi. It's actually easier to count in radians. Okay. So, for cosine, I'll draw myself a reference circle. I'm going to start at 0. Remember, cosine over here is the x value. So at the angle 0, I've got an x value of 1. So cosine of 0 is 1. Cosine of pi over 4, which is 45 degrees, cosine is the x value. It's going to be positive square root of 2 over 2. So at pi over 4, positive square root of 2 over 2. At pi over 2, my x value is 0. My dog's drinking water. Can you hear that? If so, it probably sounds weird. 3 pi over 4. Right there, the x value is negative square root of 2 over 2. At pi, the x value is negative 1. At 5 pi over 4, the x value is negative square root of 2 over 2. At 3 pi over 2, the x value is 0. At 7 pi over 4, the x value is positive square root of 2 over 2. At 8 pi over 4, which would be 2 pi, the x value is 1. And it continues repeating. Square root of 2 over 2, 0, x value, negative square root of 2 over 2, 3 pi, negative 1, negative square root of 2 over 2, 0, positive square root of 2 over 2, and at 4 pi, the x value would be 1. And now I connect the dots. It's easier for me to go from right to left. I don't know why. Probably because I can see around my hand. So there's cosine. It looks like that. And again, we get two complete periods. So one period could be, say, from here to there. We've got two waves. Down and then back up. Down and then back up. So it doesn't really matter where you measure the period from. It's one complete repetition. So here the period would be, say, from there to there. Or you can measure it from here to there. But then that leaves you with a weird leftover bit on the end. So one period, two periods. Okay, now that you know how to graph sine and cosine, let's try to graph some transformations. So we're going to graph 1/2 of cosine of x on the interval from negative pi to 2 pi. So first I'm going to draw some axes. Okay. Now I'm going to label these, because my interval is given in terms of pi, I'm going to label them in pi's. So I'm going to use pi over 4, just like I did on the last problem. So there's pi over 2, there's 2 pi over 2, or pi, there's 3 pi over 2, there's 4 pi over 2, or 2 pi, and then in the negative direction, same thing, negative pi over 2, negative 2 pi over 2, so negative pi. Okay, now I'm going to start just by drawing cosine of x. And to do that, I'm going to grab a pencil, something else I don't see as well. Here's a black pen. Okay, so we said to start at negative pi. So first I'm going to draw myself a circle over here, to use as a reference. So negative pi would be right there. Cosine is the x value here, so my x value there is negative 1. So at negative pi, I should have negative 1 as my value for cosine. And then at negative 3 pi over 4, I should have a cosine value, an x value of negative square root of 2 over 2. And then at pi over 2, I've got an x value of 0. And then at negative pi over 4, I have an x value of positive square root of 2 over 2. And then at 0, I have a cosine value of 1. Okay? And so, by now you should see this pattern. We alternate from 1, then square root of 2 over 2, then 0, then square root of 2 over 2, 1, square root of 2 over 2, 0, square root of 2 over 2, 1, square root of 2 over 2, 0, square root of 2 over 2, 1. Like so. So this is cosine. Now, we want to graph half of cosine. By the way, I should label my y-axis. Here's positive 1, and here's negative 1. Okay, cool. So in red, I'm going to graph half of cosine. So this half is multiplied by cosine, so it's going to be a stretch or shrink, and specifically here a shrink. And it's on the outside of the function, so it's affecting the y values. So I'm multiplying all of the y values by 1/2. So for instance, if I multiply the y value here by 1/2, the y value is 1, half of 1 is 1/2. if I multiply the y value here by 1/2, it's 0.7-ish, so I should get like 0.35, something like that. Same thing for this guy. So all of these are getting half as far away from the x-axis. So that's going to happen to all of my y values. Now if it's already 0, it can't get any closer to the x-axis, but square root of 2 over 2 is going to become square root of 2 over 4, or 0.35, and then a 1 is going to become a 1/2. So I'm going to shift all of these closer, twice as close to the x-axis. Twice as close. 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 And connect them with a dot. With a line, sorry. Okay, so there's my drawing, my graph. So this would be, in red, 1/2 cosine of x. And then in black, the original cosine of x. So start by graphing cosine of x, and then apply whatever transformation you need to. In this case, a vertical shrink by 1/2. Next, graph sine of x plus pi over 2. So, I'm going to graph again from negative pi to 2 pi. Didn't leave myself a whole lot of space. Okay, so since I'm kind of in a skinny hole here, I'm going to put 1 there and negative 1 there. And I'm going to count off again, because I'm given these values in radians. So pi over 4, pi over 2, etc., etc. There's pi, there's 2 pi, and then backwards, negative pi over 2, negative pi, like so. Okay. Now, I'm going to start by graphing sine of x in black. So, sine of x. Here's a visual aid to help me graph this. So, let's start at negative pi. Sine of negative pi, sine's the y value, so it's going to be 0. Sine of negative 3 pi over 4, sine's the y value, negative square root of 2 over 2. So I'm going to start down. Oops, not that far. I'm going to start down. Then sine of negative pi over 2 is negative 1. Sine of negative pi over 4 would be negative square root of 2 over 2. And by now you probably recognize a familiar pattern. Sine of 0 would be 0. Sine of pi over 4 would be square root of 2 over 2. So a little more than halfway, 0.7. Sine of pi over 2 would be 1. And then square root of 2 over 2, and then 0, and then square root of 2 over 2, and 1, and square root of 2 over 2, and 0. Repeating pattern. You really just need to get the pattern started. Okay, so there is sine of x. So sine of x plus square root of 2. So we're adding to the x value. Anytime we add or subtract, we are translating or shifting. Because it's being applied directly to the x value, it's inside the parentheses in other words, it's happening to the x-axis. So it's going to be a horizontal shift. And anything that happens inside the parentheses happens the opposite. It says plus pi over 2. Well, we're actually going to take the x values and subtract pi over 2. So we're going to be going to the left pi over 2. Now I'm going to extend my axis out a little bit so that I can do this. Okay, so this would be a negative 3 pi over 2. So, basically, I'm going to take all of my points, shift them back by pi over 2. So take that point and shift it back. Take this point and shift it back, like so. This point, back. This point, back. This point, back. This point, back. So I'm counting back 2 marks for each point, because that's how far pi over 2 is the way I've graphed this. This one, to the left, pi over 2. This mark, to the left, pi over 2. This mark, to the left, pi over 2. This mark, to the left, pi over 2. And so forth. So I took each point from the original graph, and then I moved it to the left by pi over 2. Now I'm going to connect my dots. And I get that. Okay, last one. F of x is 3 times cosine of 2x minus pi plus 1. We want to give the amplitude, the period, the frequency, the phase shift, and the center line. Okay, well, the amplitude's easy. Remember, the amplitude is the absolute value of A. A here would be 3. So it's the absolute value of 3, which is 3. The period. The period is always the original period of whichever function we're dealing with. Cosine, which has a period of 2 pi, a full circle. And then we divide it by b, the absolute value of b. So the absolute value of 2 is 2. So 2 pi divided by 2, which is pi. So the period is pi. Frequency is 1 over the period. We said the period was pi. So the frequency is 1 over pi. That easy. Phase shifts. The phase shift is c, negative c, divided by b. So negative c would be a positive pi, because it's negative pi there. So negative c divided by b, which is 2. So pi over 2. That would be the phase shift. In other words, everything got moved to the left. To the right, sorry, by pi over 2. Take that pi, then divide it by the 2. And the center line comes from a vertical stretch. This is C, by the way. The center line comes from D. Sorry, a vertical shift, not a vertical stretch. Center line comes from a vertical shift. Our whole graph gets shifted up 1. So our center line, instead of being centered at y equals 0, like, say, these graphs above, it's going to be centered at y equals D, which is 1. That's it. We'll work more on this in class next time. And, yeah, you should be able, first off, to graph sine and cosine. The rest is just basic transformation stuff that we've done for lots of other types of functions. So if you have any questions, let me know.